expected value, variance, and standard deviation of discrete random variable. The expected value is the average value attained by the random variable. For example, if you are going to do the experiment several times, you will have the expected value, which is the average attained by the random variable. The expected value of a random variable is also called its mean, in which case we use the notation mu of x. The expected value of a random variable is also denoted by e and then the random variable x. Thus, mu of x is equal to e of x. For example, if 3 coins were to be tossed 10,000 times, and the random variable is the number of heads that turn up, what is the average number of heads that will turn up? So the answer here is the expected value. Or what number of heads will most likely turn up? So that is what we call the expected value. If x is a discrete random variable associated with an experiment, the expected value, or in other words, mathematical expectation of random variable x, is defined as this formula. Example number 1, compute the expected value of the random variable x, the number of heads that turn up if 3 coins are tossed 10,000 times. So this is the probability mass function. 0 head, the probability is 1 over 8. 1 head, the probability is 3 over 8. 2 heads, the probability is 3 over 8. And 3 heads, the probability is 1 over 8. So that's the probability mass function. All you need to do is to multiply this, the number of heads, by the probability. 0 times 1 over 8, 1 times 3 over 8, 2 times 3 over 8, and then 3 times 1 over 8. And then you will be using the summation function. So you will add all the values. So the answer is 3 over 2, or 1.5. This 1.5 is what we call the expected value of the random variable x, the number of heads that turn up if 3 coins are tossed 10,000 times. Next, number 2, compute the expected value of the random variable y, the positive difference between the numbers that turn up, in rolling a pair of dice if this is done 10,000 times. So again, the formula is this, and this is the probability mass function. So 0, the probability is 1 over 6, 1, the probability is 5 over 18, and so on and so forth. Now all you need to do is to multiply the number 0 by the probability 1 over 6, 1, 5 over 18, 2, 2 over 9, and so on and so forth, and get the sum. That's 35 over 18, which is approximately 1.94. So this 1.94 is the expected value of the random variable. So most likely between 1 and 2, but 1.94 is closer to 2. So most likely the number that will turn up is 2. Now let's have the variance and standard deviation. These give a measure of spread for random variables. So standard deviation is interpreted as a measure of how spread out the possible values of the random variable are with respect to the expected value or mean of the random variable. Variance is the square of the standard deviation, which means that standard deviation is just the square root of variance. So the formula is this one. Okay, let's have an example of that. Compute how spread are the values of the random variable x, the number of heads that turn up if 3 coins are tossed 10,000 times. So again, the expected value is 1.5. And then we have the e of x squared. All you need to do is to square first the number 0 squared, and then you multiply by the probability 1 over 8. 1 squared times 3 over 8, and so on and so forth, and then get the sum. The sum is 3. Then after that, you will subtract. So e of x squared, that's 3, minus e of x, or the expected value, squared. So that's 3 over 2 squared, because the expected value is 3 over 2. So 3 minus 3 over 2 squared is 3 over 4, or 0.75. That's the variance. Now for the standard deviation, the square root of 0.75, which is equal to 0.866. This means that the values of the random variable are spread 0.866 from the expected value.